Hello, and welcome to Coffee with Chris. I'm Chris McBain. I'm going to be your host today. I'm coming to you from my shop, and I wanted to do a quick demonstration of really the basic functionality inside of GibbsCAM. This is really good for those of you that may not have seen GibbsCAM in a long time or seen GibbsCAM for the first time. I started using GibbsCAM back in a model shop in Chicago around 1996. I had used a lot of CAM systems between then and being brought on with GibbsCAM now at 3D Systems. And when I got back up into the program itself, it was amazing to me how fast it was to get back up to speed. I'm going to show you that here. And one of the biggest reasons is the things I'm going to show you today, they're universal across all of GibbsCAM. The geometry creation, the menus, how you pick geometry, toolpath parameters, menus, tools, creating tools, all of these things are really standard across all of GibbsCAM, whether you're doing 2-axis milling, 5-axis milling, turning, mill turn, all that stuff. You're going to see that there's a lot of common functionality across GibbsCAM. So I've got my coffee. Go ahead and grab yours, and we'll go ahead and get started. So in GibbsCAM, you can create your own geometry, or you can import solids. I'm going to show importing a solid. We're going to just come up here, say File, Open. And we can see here that you can open up a lot of very specific programs, files from specific programs, SolidWorks, SolidEdge, CATIA. There's also a lot of generic file extensions like IGES. You can open up STL files. Step files are always good ones. Those are the ones that I kind of prefer when people send me stuff if it's not a native GibbsCAM file. So this is a solid that was actually imported from another program from SolidWorks. So this is what it looks like when we pull it up. So what I wanted to do is I wanted to start out by going over some of the menu icons. Now, I'm not going to take up time and bore you guys with going over every single icon, but I just want to give you kind of broad strokes on what these do. So we have these icons across the top and the upper left here. What these are all to manipulate what you see. So the view, what you see, how you see it, things like that. Show geometry, show dimensions. Here we can show solids. Here it gives us options of showing wireframe or no wireframe in the solid. All kinds of stuff. So here's our stock and origin, and here's our coordinate system. So this is where you can turn on and off. Over on the right hand side over here, this is where the rubber meets the road. This is where we're going to do a lot of the actions to the part, programming it, maybe changing it, making geometry, modifying geometry, and things like that. So what I like to do is I like to start out, I work from the top down usually, but really I like to open up this view palette. And this is very specific to Gibbs. You guys probably have seen this before. This is the view to manipulate the view. T stands for top of the part. This is my isometric, and I'm going to go ahead and just fit that. Great. So next is, do I want to create any geometry for the part? Now, when you pull a part into Gibbs, you can imagine if you pulled in, let's say, an STL file, if Gibbs pulled in all of the data, all of the wireframe was selectable, all the surfaces, all this stuff, the file would be enormous. So what Gibbs does is it allows you to kind of pick and choose what geometry you want to use and import. So let's say, for instance, I'm going to go ahead and turn on edge selection. I'm just going to pick this edge, and I'm going to say extract edges. So what that does is that gives me a line that I could use, and I can extract a lot of things. I can do surfaces. You are able, with solids, you are able to select solids or surfaces with machining. But let's say I wanted just one specific surface or something like that, I can pull that off the model, no problem. Okay. So that's the geometry, and these three buttons, this is where you're going to spend most of your time. So this is your tool creation, and then this is my CAM button. So what this does is it opens up my machining palette, which is basically what I want to do. Do I want to do a contour? Do I want to do a rough? Do I want to do a surface, 3-axis, threading, things like that. And then down here, this is my processes. So this is kind of like the work in progress. This is the toolpath that I'm working on right now. And then last but not least, over here, this is my operations. This is actually what's going to be posted to my machine. Okay? So first thing I want to do is I want to set up where my G54, my home position is. You can see when GibbsCAM comes in, it's kind of, there's the home screen. It's usually where this was modeled originally. So again, working from the top down, I'm going to go to coordinate systems. So whenever you open up a part in GibbsCAM, you always have this XY plane. Now, you can take this model and move it down to the appropriate place in that coordinate system, or you can just create a new coordinate system and use that new coordinate system to machine off of. So that's what I'm going to do. I'm going to say, let's go ahead and build a new coordinate system. And right here, this is modify my coordinate system. So I'm going to go ahead, for my new coordinate system, I'm just going to change the origin. And I'm going to hold down Alt-Shift, and I'm just going to pick this and hit do it. And you can see that it's that easy. Now I'm ready. That's my G54. This is my 0 plane. I'm all ready to machine this part. Okay, so we can see as we continue on here, we start to get a lot of stuff on our screen. You can see I have my grid for my active coordinate system. I have some geometry, things like that. So again, these little buttons up here, this affects what I see. So let's turn off the geometry. I'm going to go ahead and I'm going to turn off my coordinate system. Okay. So next I'm going to turn off my stock. So I just have my parts. So I like to keep my workspace pretty clean. So let's go ahead. I want to move on and talk about geometry creation or modification. GibbsCAM comes with what we call CAD for machinists. You can build pretty much any part you want in it. It just doesn't really work the same way as, say, an engineering CAD system. It's really geared towards CAD the way that we as machinists need to use it. Creating simple geometry for bounding blocks, for stock, modifying simple things in parts. Let's say we want to put a chamfer or a radius on a corner, things like that. It's really tailored to what we as machinists use it for. It's very powerful. Like I said, you can pretty much build anything you want in it, but it really is geared towards the machinist and what we use it for. So I just want to show you just really quick some geometry creation. If we look over here on the left-hand side, like I said, we work from the top down. Here we have our surface modeling, so we can model surfaces, or solid modeling. So you can see with our solid modeling, we have a ton of stuff we can do. We can join things, we can replace it, we can subtract if you want to make a mold core or a mold cavity, we can do that, extrusions, things like that. But some of the things we do, let's say we just want to go ahead and we want to put just round these corners off. So I'm going to go ahead and turn on my edge selection. I'm going to go ahead and select all these corners and go ahead and click do it. Boom, that's it. So it's really easy, really simple, it's really straightforward. Actually, I find that when I'm using some engineering software, whatever it is, it can be a little overwhelming with as much. I just want to round these corners. That's all I want to do. I just want to put some fillets on these corners. That's all I want. GibbsCAM makes it really easy to achieve that. Okay, so let's get down to business and let's talk about putting toolpath on this part. All right, so we've got this part, it's ready to go. Now, whenever I start out with a new software, if I'm learning a new software, the biggest hurdle that I find, and really what I've found, teaching CAM throughout the years is, people, they know what to do. Like, we're all machinists, we know what we want to do, we just need to find the right buttons to do it. So with GibbsCAM, it makes it really easy. Like I said, across the top, this is all the view stuff. I want to look at this different. I want to change the colors. I want to change the way it looks. I want to see the wireframe. I don't want to see the wireframe, things like that. On the action I want to take is over here. So again, I'm going to start from the top down. So here's my documents. This is how I set my machine. If you only have one machine, you're going to set this up in the beginning, and you really don't have to mess with it again. Here's our stock and part origin. So if we want to change the size of our stock, this is where we would do it. We would just go ahead and put in the stock size here. If we had more than one machine we were programming to, you can see I have a whole bunch here. You would just go ahead and pick that machine. But if you only have one machine and you're just doing pretty basic stuff, you're just going to leave that. You don't even have to worry about that. I showed you some geometry creation. So next, let's talk about this stuff here. So I want to go ahead and create a tool. So again, I create a dialogue in my mind. What am I trying to do? I want to rough this pocket using a 1/2-inch end mill. Okay. So first thing I'm going to do is, working from the top down, I'm going to make a 1/2-inch end mill. So here's all of the options that I have for creating tools inside of GibbsCAM. So we have our roughing end mill, our finish end mill, ball nose. We have a convex tip. You can go through all these. We have all kinds of stuff: drills, taps, spot drills, things like that. We can make them in inch or metric. whatever. I'm a big fan of the standard inch, so we're going to go ahead and leave that where it is. And here's my tool specifications. Okay, so this looks good. I'm going to just go ahead and use this. So what did I say I want to do? I wanted to rough this out, right? So here's my machining palette. So this is what I want to do to the part. Do I want to drill holes? Do I want to just create a contour? I just want a tool to run around a line or a profile. Do I want to rough out a cavity? Do I want to machine specific surfaces, do thread milling, and then here's some advanced 3D and 5-axis, and then last but definitely not least, volume mill, which volume mill wireframe, so 2D volume mill defined by wireframe is included with all of the GibbsCAM packages, so you're going to have that ability too. So I said I wanted to rough, so it's just drag and drop. This is like old school, super simple stuff. I'm just going to drag that tool, and I said I wanted to rough. So I want to rough using that tool, and I want to rough this surface here. Okay? So here is everything I need to know about my tool path. Every setting is inside of this window. What it's going to look like, I want to offset with cleanup, things like that. Solids, what I want to do when it hits an open air side, things like that. All right. This is really where the majority of your settings are going to be set. These over here in the end, they're more advanced things, and you know, there's definitely times you use them, but you may not use them very often. Most of the time it's going to be right inside of this first window. All right, so this is one of the things I really like about Gibbs. It doesn't matter where in the Z your geometry is. All right, and what I mean by that is, so I want to machine this surface. I don't need to know the distance between the top and here. I don't need to set any of this stuff. I don't need to like go in and say this surface is this. I'm going to hold down my Alt key. I'm going to highlight this, hit my Alt, and click on that surface. That's my 0. And then click on this surface. That's negative 0.75. So the toolpath's going to start at 0. You can see that's the top of the surface. Start at 0, and the pocket's going to end at 0.75. All right. So once I have all these parameters set, my speeds, my feeds, my contour feed, which is going to be a little bit bigger than my entry feed. I want to use stock, things like that. And more importantly, and this is something right we change a lot, is my desired Z step. So I have a 1/2 inch cutter. Let's go ahead and I'm just going to change this to 0.25. And you can see as I do that, there's my step, and the actual number of passes is 3. So really easy stuff. I have all my settings right here. I'm going to click do it. And then there's my tool path. Okay, so this is fine, but you can see it's going around these holes. I don't want to do that. I want it to machine over those holes. Now, there's a couple different ways to do this, but one of the easiest ways is just kind of change the definition of the pocket of what I used. I picked that surface, so you can see that there's gaps in the surface. That's what it's going to do. So what I want to do now is I'm going to go ahead. I'm going to use the wireframe. So remember in the very beginning, what I did was I selected that wireframe. And set extract features. So I'm going to do edge select. I'm just going to double click on that edge. I'm going to select the edge all the way around. I'm going to right mouse button click, and I'm going to say extract edges. Do it. There we go. Okay, so now I've extracted those edges, and I want to go ahead and come over here, and I'm going to just go ahead and say, you know what, now I want to redo it. You can see that. Let me turn this off so we can see a little bit better. I'm just going to go ahead and select that all the way around. And now I'm going to click redo. So it's going to redo that tool path inside of there. Okay, so now one thing I want to show is you can see here that this is open air, but the tool path ends before it gets there. So really what I want to do is I want the tool path to go past that edge. This is so easy to do in Gibbs. This is one of the things I really like. So we can go ahead and right mouse button click, and it says change feature from wall to air. So I'm going to do that, and I'm going to click redo. So now we can see that the tool path goes over that edge. So at this point, I can go ahead and I can simulate this tool path. So let's go ahead and turn the geometry off. So there it is, machining the part. Okay, so that's just roughing out that pocket. So let's talk about machining these 4 pockets next. Okay, so I want to machine these 4 pockets. So obviously my 1/2-inch cutter, it's not going to fit in there. It's got to be a little bit smaller. So I had to create a new tool for it. So I'm going to just come over here. I'm just going to double click on tool number 2, and I'm going to change this to an 1/8 inch. All right, so I have an 1/8 inch cutter, great. So now I want to machine these. So how do I pick these surfaces? There's a couple different ways to do it. I can go ahead and I can select all of the wall faces for that and then use that geometry. But because it's 2-axis, we have this thing called a profiler. And what this does is, remember how I'd extract that geometry? This is a way to create selectable geometry without having to extract the edges. So for instance, these 4 pockets, if I had 40 pockets, it might take a little while. Double click around, extract geometry, and then I have to put it on a layer and all this other stuff. Really, I just want to use that geometry to machine this part. So I'm going to use the profiler for this. So I'm going to just come down here and I'm going to drag my tool number 2 down, and I'm going to go ahead and I'm just going to rough it out again. That's totally fine. You can see that it automatically changes the cut width. All right. So we can see here that, here's my retract planes. This is great. The top of the part is at 0, but the bottom of the part, it's not at this surface, it's at the actual bottom of the part. So the bottom of the pocket, because these are through holes, they go all the way through the part. So what I can do is I'm going to hold down my Alt key and I'm going to click towards the bottom of the surface. What that'll do is Gibbs will automatically pick the lowest point on that surface. So now I just have to go around and I'm holding down the control key and just select my pockets. Now remember, I don't know what the height of those pockets are, but it doesn't matter because I'm telling Gibbs I want to start at 0 and I want to end at -1. So it's automatically going to start the tool path using those features or those boundaries. It's going to start at the top and go all the way to the bottom. So again, I'm just going to click do it. And you can see that there it goes automatically, and it goes and roughs those pockets out. And if we look, as I'm going through this, I'm creating these. On the right-hand side, it's actually creating my operations. So I can actually come here and repaint and look and see each one of these operations and how it works. Okay? Great. So we'll go ahead and repaint that. Perfect. Okay, so next what I want to do is I want to go ahead and drill these holes. I want to drill these 2, 4, 6, 8 holes. This hole in the middle is actually, there was a design change, and I want to get rid of that hole. I'm going to show you how easy that is using my solids tools inside of GibbsCAM. So all I have to do is I open up my solids palette. I just want to click on that and say unstitch solid. And what that does is it just plugs up that hole. So now it's just like it doesn't even exist. It's perfect. Okay. So what I want to do is I want to, again, drill and countersink these holes. What takes a lot of time is creating the tools, the center drill, countersink, and then selecting the geometry, creating hole features, all this other stuff. In GibbsCAM, we have this thing called the hole manager. So what this does is using a wizard, using this menu that you see here, it's going to automatically pick up the holes, create tools, and put toolpath on these holes for us. So it uses this technology called automatic feature recognition. So I'm just going to go ahead, I'm going to select my solid, let me turn off surfaces here, and I'm going to say go ahead and run automatic feature recognition. So we can see that it created all of these holes for us, all of these 8 holes. Let me move this over a little bit so we can see it. So right here is show hole features. So there's our hole geometry, there's our hole features. So now it created the features. Now I want to go ahead and I want to put toolpath on them. So I'm going to say auto group. So it's going to group those holes into specific groups. And I'm going to hit auto whiz. And what this is going to do is this is going to create all of those tools for me and create the drill processes for me also. So now when we go ahead and we simulate this toolpath, we can see that we get all of those holes that are drilled and countersunk. And GibbsCAM has automatically created those tools for us. So drilling holes inside of Gibbs is really, really easy. All right, so here you can see that we have a pretty complete part programmed. It's great. I want to show you how these, and I just really briefly, because we're running out of time here, I want to show you how a lot of these fundamentals roll over into some of the more complex Gibbs applications. But before I do that, I wanted to show posting. So yeah, it's all great, but right now all we have is a cartoon. We want to shoot this out to the machine and make this part. So again, it's working from the top down. So I simulated it. Now I want to go ahead and post it. So I just go ahead and I pick a post processor, and then I pick where the posted code is going to go. I can see an example of the code here, and I go ahead and hit process. It just says make sure you check it, and then there is the posted code. Okay. Okay, so here we have a little bit more complex part. I've got a bunch of different pockets. It's a two-sided part. You can see there's some stuff on the bottom here that needs to be machined. There's angular holes. And I want to machine this using a 4-axis strategy on just a Haas with a trunnion. Okay, so we can see as I open this up, and again, I don't want to go through, I don't want to bore you guys with all the details of creating planes, all this stuff. I just want to go over what I did. So I created a couple planes here, and in these planes I created them on angles to match those holes. Really easy to do. I just create some normal planes to these hole surfaces. It's really easy to do inside of Gibbs, and then I create some drilling on them too. So you can see that it's exactly the same. Here's my tools, right? Here's my tool tab. We looked at that. That looks exactly the same. If I make an operation, you can see that here's my operation tabs. Same. There are my process tabs. And then over here is my operations. I can turn off my geometry. I can see my geometry. I can turn off planes, my coordinate systems, things like that. So all of this is the same. Now, when it comes to visualization now, when I start getting into more complex parts, I can do what's called machine simulation. With machine simulation, we can load a machine model and actually see how this part looks as it's being machined. Okay, so here I have this machine model of my Haas, and I'm just going to slow it down just a little bit, and I'm going to hit play. So that's pretty fast. You wish your machine would go that fast, right? Let me slow it down even more. Back it up. So here I can actually see, and I can stop it. Here it's center drilling the hole. I can actually see the way it's mounted and things like that. What I wanted to show you by showing you this is, yeah, sure, it's pretty simple to make tool paths, but it's also very powerful as far as what you're able to do just by creating different machining planes and defining your machine a little bit differently. For instance, here I have my 4-axis Haas with my machining preferences, my comments, things like that, intermediate tooling. Like, there's a lot of power behind this that allows you to do some really great machining, but you're still using those fundamental easy steps inside of Gibbs. And like I said, it's just creating a dialogue. What do I want to do? I want to drill a hole using these tools on that angle. It's that easy. Okay, so that's just one example of milling. So I wanted to show you an example of a very complex part. So this is the other end of the spectrum. This is going to be a mill turn example. So what we call MTM example of how Gibbs is powerful and can help you. So let's go ahead and open up that part right now. Okay, so here we have, you can see it's a much more complex part than what we've seen so far. There's milling and turning, mill turn all at one time, things like that. So I want to show, again, it's exactly the same as what we were looking at before, even though it's a complex part. Start from the top down. We're going to do it on a citizen machine. Here's our interop positions. Sure, there's a few more settings because it's a more complex part, but you can see that all the menus are the same. So we're going to come down here and we're going to look at the tool paths, and I'm not going to go through programming this whole part. You can see that there's a lot of programs here and also a lot of tools. Let me go ahead and expand down this tool list here so you can get an idea. So here, because it's a mill turn part, we have both milling tools and turning tools all within the same library that we're going to use. So let's go ahead and we're going to go ahead and take a look at that. All right, so I wanted to show in this, you can see that here's our turning. This is a mill turn, so here's our turning processes that we can define, or we can go ahead and put in a milling, and this is what we've been going through so far. But with this, you can see that with all of these operations, it's very important to get a good visualization, and that's really where GibbsCAM comes into play, is getting you good, accurate tool path as quickly and easily as possible. All right, so we're talking about real power right at your fingertips to create these tool paths. So let's go ahead and we're going to go ahead and do a machine simulation on this. I want to show you how well GibbsCAM simulates the machine on this. So I'm going to rotate this around. We can see, let me zoom out here. You can see that it's basically the whole machine. I have the outer part of it translucent so we can see through it. Let's go ahead and zoom in on the parts, and let's go ahead and press play. So we can see by programming, let me zoom out a little bit so we can see that top one. By programming the part and loading the machine, we get a really good representation of what it's going to look like as far as tool clearances, things like that on this part. And this is, again, you can see back here, let me move this over. It's actually doing two operations at the same time. If we go down the list here, and you can see there's the part transfer. So using the same very straightforward menus that I've shown you so far as what gets posted, tool creation, and operations that or processes that we're working on, we can do not only really simple parts, but using all the same principles, we can program very complex parts inside of GibbsCAM. So I'm going to stay online and answer any questions. I can see that there's some questions that came through, so we're going to sit here and go through those questions. Thanks a lot, and we'll talk to you soon.